Oh, welcome back for another edition of Mr. Twilliger's Geometry. Today we're going to be talking about Section 3-4, parallel and perpendicular lines. Okay, now you may be asking, why do I need to know about parallel and perpendicular lines? Well, when they build a house, first thing they have to do is find the corner edge and make a right angle. They do that using actually old techniques. They don't measure it. They don't use a protractor. They go ahead and they find their perpendicular lines, and then they make sure the walls are parallel to each other, because if it's not, your house won't be as stable. So why do you need to know this? In case you go into construction. Okay. 3-7. If two lines are parallel to the same line, then they're parallel to each other. Think about this we'll call it the parallel transitive property. Because if A and B are parallel, and B and C are parallel, then A and C are parallel. Okay? Again, it's your transitive property of parallel lines. And it's going to end up kind of working with perpendicular too in a way. Okay, so if A is parallel to B, B is parallel to C, A is parallel to C. Okay. Here's going to be theorem 3.8 for you guys. In a plane, two lines are perpendicular to the same line, then they are parallel to each other. Okay, so if M is perpendicular to T and N is perpendicular to T, then they're parallel. Again, think about train tracks. If you draw on your train tracks, and each one of these is 90, you know that those train tracks are going to be parallel. Because, I can actually go like this and go those. Again, because if that's 90, that's 90, so your corresponding angles are congruent. And if that's 90, this is 90, this is 90, this is 90, this is 90. They're all 90. So all your theorems from before hold true. Your alternate exterior are congruent, your same side interior add up to 180. So you know those guys are parallel. Get rid of that mess. Okay. Let's take a look at this. Can you assemble a picture frame with these angles where the opposite sides are parallel? What do you guys think? I'm actually going to make this one kind of homework to try on your own. Okay, so come in with your solutions. Think about it. We're going to talk about that in class next time we see each other. My big thing is just think about what angle those add up to and draw a picture. Okay? Let's talk about your perpendicular transversal theorem. In a plane, if a line is perpendicular to one of two parallel lines and is also perpendicular to the other, this is the opposite of what we just said. This says if L and M are parallel, which they are because we have these arrows, this parallel line deal, it says if N is perpendicular to one, it's perpendicular to the other. Again, that just holds true because if this is 90 degrees, by corresponding angle theorem, that has to be 90 degrees. Okay? If that's 90 degrees, they're all 90 degrees. Okay. I'm going to give you guys a second to think about that, read it over. A lot of information just got pushed into your brain. We're already 60% of the way through these notes. And I do have a joke for you guys. What kind of dance do you do on a trampoline? Hip hop. I'll let you think about that one. It's pretty deep. When I heard it, I was jumping for joy. Okay. Tricky proof. Okay. In a plane, we have C is perpendicular to B. Okay. B is perpendicular to D. And D is perpendicular to A. Okay? So, here's what we're going to do. Alright, so first things first, I'm going to make my good old proof box. Okay. Oops. Flash drive just got pulled out. That'll be fine. So our given is C is perpendicular to B, B perpendicular to D, D perpendicular to A. Okay? So we want to prove that C is going to, if we extend it, will be perpendicular to A. Okay, there's two routes to take. If you want in your book on page 166 is one way, I'm going to show you guys another way, so you have two different ways. Okay, so first thing I'm going to do is say A is parallel to B, because both these angles are congruent, right? So that's your converse of corresponding angles. Oops. Right? Because these two, your corresponding angles are congruent. Two lines crossed by transversal, corresponding angles congruent, those two lines are parallel. Okay? So, I'm going to go right to it and say then, C is perpendicular to A. And that's by a theorem with parallel lines crossed by transversal and transversal is perpendicular to one line. It's theorem 3.9, the perpendicular transversal theorem. Okay? Is perpendicular to the other. So we proved these two are parallel. Then we said, well, this one's perpendicular to B, C is, so it has to be perpendicular to A. Again, look on page 166, guys, for the other one. And we're going to talk about that in class too. Okay, again, this was 3.9. Think about it, ponder about it. Take a deep breath. Here we go. Last slide. So let's say Shiro sketched coplanar lines M, N, and R on his home ring. He said that the lines M and N are parallel. What other information do you need to know about line R in order for Shiro's claim to be true? Okay. My big piece of advice to you is, well, he drew this picture, right? Where you have N and R. If I don't know what angles M is, I could draw it like this, right? So what he needed to say is one of these angles had to be 90 degrees. Okay? So one of the angles formed by M and R should be right. Because if it was right, we could use theorem 3.8 from before, and says if your transversal cuts through two lines and is perpendicular to both, then they are parallel. Okay, and that was by 3.8 theorem. Okay, so guys, make sure you ask questions on this stuff. I know it seems kind of tricky. Once you get the hang of it, it's not too bad. Alright, see you guys next video.